The first display we're going to learn how to make in our stats unit is called a stem and leaf plot. The stem and leaf plot is a good display to show how spread out the data is. We can also create a back-to-back stem and leaf plot, and that will compare two data sets on the same display. It's much easier to explain what a stem and leaf plot is when we look at it than just by trying to explain what exactly it is. Taking a look at the stem and leaf plot that I have started for you here, we're going to create a back-to-back stem and leaf plot so that we can compare test scores for 2 different hours. What you do to create a stem and leaf plot is you take a data value and you split it into a stem, in this case the tens digit, so that goes in between the bars, and then a leaf, which in our case is the ones digit, so they are organized off to the left of the stem. Taking a look at the actual scores, I will show you where they show up in the stem and leaf plot. Our first score is 87. That shows up in the stem and leaf plot where there is a stem of 8 or 80 and then a leaf of 7. So you can see from the stem and leaf plot that we had 2 data values in first hour of 87. The other one in our list is right here. In the stem and leaf plot, this data value is 42, and you can find that in our list right here. Hopefully that gives you an idea of how the stem and leaf plot is set up. And what we're going to do next is create a stem and leaf plot off to the right for the 4th hour test scores. The scores don't need to be organized completely numerically, but it's helpful to look at within each stem and then organize the data values. Our first data value for 4th hour is 53, and as I look through the rest of the data values, nobody else scored in the 50s. It's important when you create your stem and leaf plot that you space the leaves evenly. You don't need a comma between them, you just need enough space so that people can recognize they're moving on to the next leaf. When you create a back-to-back stem and leaf plot, make sure that the leaves are spaced evenly or the same way on both sides so that we can compare the data fairly. As a word of caution, when you have a leaf of 1, it's really easy to write the 1 skinny and then put the next number right next to it. But in order for your stem and leaf plot to be created accurately, you have to give the 1 just as much space as you would give a 0. Our next stem is 6. We have a data value of 67. There are no other data values that go with the stem of 6, so I will put that right under my 3, spaced as evenly as I spaced the one above it. In the 70s, we have 78 and 78, so we will have 2 leaves of 8 spaced evenly off of our stem of 7. In the 80s, we have 81, 84, and 88, so our leaves will be 1, 4, and 8, again giving the 1 just as much room as we give our other data values. And finally, in the 90s, we have leaves of 95, 96, and 99. Make sure anytime you create a display, you give it a title overall. In our case, our title overall is test scores. If it's a display comparing 2 data sets, make sure that you give each data set its own title. And finally, for a stem and leaf plot, we need a key. People need to know how we're interpreting these numbers, because you can put thousands or millions, or you can put decimal places into your stem and leaf plot, as long as you tell people what those numbers are. So I pick 1 leaf off to the left. So for my key, I pick 1 leaf off to the left, use those 2 bars that are around the stem, and pick a leaf off to the right. Tell people what each leaf means. Off to the left, the leaf means 71. You kind of read it backwards because that stem is in the middle. Off to the right, it goes in order. We get that 78 data value. Now we're going to look at comparing the shapes of our 2 stem and leaf plots. What I notice on the left-hand side of my stem and leaf plot is there were some data values that were kind of low, and then we had a group of data values that were towards the higher score. On the right, we had kind of a gradual increase in scores. I typed up my comparison for you, so make sure you pause the video now so you can get that information down. That was comparing the shapes of the plot. Now we're going to see if we can look at the plot and generally find where the median and mode are. The median is the data value that's right in the center of the set. So you can either kind of cross off data values until you get to the center, or you can kind of eyeball it. For first hour, the median is 78. We ended up with an even number of data values, so it'll be right in between 78 and 78, which of course is 78. In fourth hour, the median is between 81 and 84, which lands at 82 and a half. And just by looking at the shapes of the graph, we could tell that fourth hour would have a higher median because it in general had higher scores than the first hour class. Looking for the mode, it's really easy to find the mode on a stem and leaf plot because you are just looking for the leaf that repeats the most. Now be careful that you also associate that leaf with the stem and that you don't find leaves from different stems and claim them all as a mode. In first hour, we have two modes. We have two data values of 78 and two data values of 87. This is what's called a bimodal data set. Bi means two, so we have two modes for our data set in first hour. In fourth hour, we only had one mode, and that was 78. We already talked about how first hour has lower scores than fourth hour. We can also tell that fourth hour had the highest score at 99, whereas first hour only had a high score of 97. We can also tell the range in fourth hour is smaller than the range in first hour because the numbers are closer together. There's fewer stems being used for fourth hour than there are for first hour. The last piece of information we can get from our stem and leaf plot is where the majority of the data lies, or the majority interval. When we look at first hour, the 70s have 3 stems. None of the other intervals have that many stems. But in fourth hour, both the 80s and the 90s have 3 stems, so we have 2 majority intervals in that case. Everything that I just talked about, I typed up for you, so again, hit pause so you can get this information down. We're going to take a look at one more back-to-back stem and leaf plot and note some comparisons. First of all, notice that this stem and leaf plot is a little bit different than the one we had on the first page. We have 2 of the same stems. You will do this when you have a lot of data value for each stem and your stem and leaf plot ends up being really wide and not very tall. How you split the data is 0 through 4 will go on the first stem and 5 through 9 leaves will go on the second stem. Having 2 stems makes the shape a little bit harder to compare because not all of the similar data is in the same row. So for before exercise, note that all of the heart rates are below 80. Obviously, we would expect our heart rate to be higher after exercise. We can still see that after exercise, we have a greater spread or a greater range of data, because the data values go from a higher data value to a lower data value than they do for before exercise. So before exercise, we have data that is more clustered together. Clustered is just when the data set is similar. We can also take a look at the majority interval for each side. Remember to combine both stems together when you're looking for the majority interval. So for 50s, on before exercise, we have 5 data values. For 60s, we have 7 data values. That ends up being the majority interval for before exercises in the 60s. For after exercise, we end up with 2 majority intervals. Both the 60s and the 70s end up with 5 data values. It appears that in general, the heart rate increases by about 10 beats per minute after we exercise. To find the median, I kind of went through that pretty quickly on the first page, so I'll show you a way to use the stem and leaf plot precisely to find the median. You start by crossing off the lowest data value and the highest data value one at a time until you get to the center of the data set. Make sure when you do the highest data value, you start at the end of the row of leaves, and to cross off the lowest data value, you start at the beginning of the row of leaves. For before exercise, we had a median of 61. We'll look at that again for after exercise. So I'm going to start by crossing off the lowest data value and the highest, lowest, highest, lowest, highest. Notice I started at the end of the row that time, and I'll continue crossing off one low and one high data value until I end up in the center. I missed one there. We end up with a median of 71 for after exercise, which based on the majority interval, we said the heart rate tends to increase by about 10 beats per minute after exercise, and the median proves that that seems to be the case.